going to start the first chapter of mathematics, that is relation and function. We know the several things about relation and function in standard 11th also. First topic is relation. I recap or I revise the definition once again to you. See, the definition is very simple. Relation, we know very well that any subset of A cross A is said to be relation on set A, which denoted as set R or set S. It means a relation is also a set. We know that. See, one simple example is this. A set R is ordered pair AB, where A plus B is less than or equal to 4, where A and B belongs to N. Now see here, AB types of ordered pair we have to arrange in such that the sum of this both number is either equal to 4 or less than 4. So which kind of ordered pair will be there? Suppose we put A is 1, then 1 comma 1, first ordered pair, because 1 comma 1 satisfying the relation. This is called a relation. 1 comma 1, so 1 plus 1 obviously less than 4. 1 plus 2, 3 is less than 4. 1 comma 3 is also there. But 1 comma 4 we may not write in this set, because 1 plus 4 is 5 and 5 is not less than 4. So 1 1, 1 2, 1 3. That after 2 1, 2 2 and 3 1. So this 6 ordered pair we may write as per the given relation. So this is called a relation. And see, this set is also subset of set n cross n, because we know that n is a very large number set. So all positive integers including in that set. So n cross n is very large set, and this set is obviously subset of this n cross n. So this is called a relation on set n. Okay, we may write this relation in very short. Because of that, we are not discussing in each and every example that the curly bracket this set. We may write in short. See, 1 is related to 1, so we may write it as 1 R1. What is the symbolically representation? This R. This R means it represents the relation 1 is related to 1. Similarly, see here, 1 is related to 2 also. 1 is related to 3 also. I am not mentioning that. 2 is related to 1. 3 is related to 1. Now see, these two examples are very important. 4 is not related to 1. This is the symbol. 2 is also not related to 3. Why? Because of that 2 3 types of ordered pair is not including in this set. 4 1 types of ordered pair is also not including in this set. So these two are not in this relation. So this is one basic and simple example of relation. You know that example very well. Now see, one remark. There are 3 big important remarks related to this topic. If number of A is n, it means a set A including n elements, then number of relations on set A are 2 raised to number of A cross A. For example, set A have 2 elements only. Then we know that A cross A have 4 elements. Now see how many number of subsets we may arrange. 2 raised to 4. 2 raised to 4, that means 16 subsets are there, and this all 16 subsets or different subsets are known as relation. So see here, 2 raised to n square. These are the number of possible relations on set A. For example, okay, I mentioned here A have 3 elements. See, this set have 3 elements, 1, 2 and 3. Then possible relations are 2 raised to 3 cross 3. It means 2 raised to 9. It means multiplying to 9 times 2 raised to 9, that is 512. So possible relations are 512 relations are possible. So this is very important. This is actually formula now, that number of relations are 2 raised to n square if set A consists n. Now my dear friends, suppose a relation is from set A to B, for example, and now we have to find the number of possible relations. So first we have to find A cross B, and then verifying that how many elements are there in set A cross B. That after 2 raised to that number of elements, it means suppose A has n elements, B has m elements, then A cross B consists m into n elements, and in that case 2 raised to mn, these are the number of possible relations. So remember it. Second thing, it is not necessary that A is related to B. It implies B is related. This is very obvious. See one example. I just give here one very important example. R is the relation. where the relation consists of ordered pair x comma y, where x is father of y. This is a social relation that x is father of y. So what do you say? X is father of y. That means y is either son of x or y is daughter of x. It means y is child of x. It means x and y are related with this relation. But obviously y and x is not related with the same relation. We may never say that y is also father of x, then it will be a very big mistake here, we know that. So it is obvious that y is child of x. If relation R is set across A itself, it means suppose we find any relation such that relation R is across A itself, then we may say that is a universal relation. Okay, one more thing I have to mention here. If any relation R is null set, empty set, then we may say that is empty relation or null relation also. So this is the thing. One example we may derive. Let us see one example related to this universal relation. Suppose we may say that set A is n. Set A is n. A relation on this set, on set n is, suppose I write this relation, R is equals to AB types of ordered pair. Now we know that relation means set of ordered pair, where A plus B is greater or equal than 2, where AB belongs to n. Now let us see what happened in that case. See here, this relation consists all of ordered pair of n cross n. Because of that, AB types of ordered pair where A plus B is greater or equal than 2. Greater or equal than 2 means either the sum is 2 or the sum is more than 2. Now we know that when sum is 2, that means 1 comma 1 is the least ordered pair we may write, or the first element of this ordered pair is 1 comma 1. Because 1 plus 1 is 2. Now 1 we may write as it is. It means first element we may write as it is. Now I change the second element in each and every ordered pair. Then the second ordered pair is 1 comma 2. Next should be 1 comma 3, 1 comma 4, and so on. There are infinitely many ordered pair we may write. Similarly 2 comma 1, 2 comma 2, 2 comma 3, and so on. Similarly 3 comma 1, 3 comma 2, 3 comma 3, and so on. And there are infinitely many ordered pair we may write. This is the relation representing this equation that A plus B is greater or equal than 2. Okay, it is very obvious that therefore this set R is itself n cross n. That's why this relation is called the universal relation. So therefore R is universal relation on set n. Universal relation on set n. Okay.